In my previous video, I explained what a support vector machine is and why we want to use it. If you haven't watched that video, you are welcome to go to my YouTube channel and watch that video first. In this video, I'm going to talk about how to tune support vector machine. As you know, there is a critical feature in support vector machine that is called kernel trick. For example, if we try to classify two groups of data like this, the red square is in the middle and the green circle are around it. If we do a transform, we can turn this two-dimensional data to three-dimensional data. And then we can use this decision surface to separate them. There are many kernels available in support vector machine. Then we have questions. First, which kernel should we use? Then, even after we decide which kernel we are going to use, we have to decide parameter values for that kernel. There are many kernels available in Python. In this demo, I'm going to use linear kernel, polynomial kernel, and RBF kernel only. Let's take a look at RBF kernel. In the RBF kernel, we have two parameters. One is C, another one is gamma. And I explained what C stands for and what gamma stands for in my previous video. If you haven't watched that video, you are welcome to watch that video first. Then let me clarify two concepts. One is called recall, another one is called precision. Think about, we have all those values that's called actual value. It's positive and negative. And we have our predicted value, positive and negative. If we predict it is positive, and in reality it is positive, then we will say this is true positive. But if in actual case it's positive, but we predict it as a negative, we will say this is false negative, because the true value should be positive. Similarly, we will have false positive and the true negative. The true negative means it is negative, and also we predicted it is negative. So recall is defined like this: the true positive divided by true positives plus false negatives. So in this graph, we consider actual positive. So it is in this column. How about precision? Precision is true positives divided by true positives plus false positives. So precision is consider this row. We consider how we separate the predicted positive with actual positive and actual negative. Now you know what recall means and what precision means. Think about this example. among 100 people, there are 2 people are COVID-19 positive and 98 people negative. If we predict 100 negative and 0 positive, then the recall will be 0, and we can't decide the precision because it's 0 divided by 0. Now we will define accuracy. Accuracy means in the numerator we have true positives and true negatives. That is, we include all the true values in the numerator. And in the denominator, we'll put true positive, true negative, false positive, and false negative. That means we will consider all the cases. And under this condition, we will have accuracy equal to 98%. This is very high accuracy, but you can see in this case it doesn't mean anything because we just close our eye and predict all the people are negative. And among the population, because most of the people are negative, so the accuracy of our prediction will be pretty high, but that doesn't mean our prediction is very good. Now let's consider the relationship between precision and recall. When recall is 0, precision is 1. And as recall increases, precision will decrease. So how can we combine precision and recall? Then we can use F1 score to do that. F1 score is calculated based on this formula. So that consider precision and recall, and the best value of F1 will be 1. That means we did perfect prediction. So in my previous example, if we predict 98 negative COVID-19 people and 2 positive COVID-19 people, we will have precision equal to 1 and also recall equal to 1. And if we put in the F1 formula, we'll get F1 score as 1. Now let's go to Python to see how can we tune our support vector machine. In this video, I'm going to still use iris data just like I used in my previous video. And also in this video, I'm going to use linear kernel, polynomial kernel, and RBF kernel only. Now, if we use linear kernel, we say C equal to 1 and gamma equal to 1. Really, in linear kernel, gamma doesn't do anything, only C matters. If we run it, you can see the F1 score. For group 0 is 1, group 1 is 0.96, and group 2 is 0.95. And you can also check that here, because there are 16 samples from group 1. They are all correct. And in the group 2, there's 1 sample off. And in the group 3, also 1 sample off. And if we change the C, say we put 10 there, we rerun that, And you can see the F1 score changed, and for the group 1 it remained the same, so all accurate. Group 2 same, but group 3 you see there are 5 samples off, and the average F1 score and dropped to 0.9 from 0.97. Now let's check out RBF kernel with the C equal to 1, gamma equal to 1. We have F1 score for group 0 is 1, that's perfect. And group 1, 0.9, that has 1 sample off. And group 2, we got 0.87. So there are 4 samples off. In average, the F1 score is 0.92. If we change C to 10, and you can see the F1 score improved, and average F1 score is 0.93. It increased from this 0.92. How about we change gamma? If we change gamma to 0.1, and you see with this RBF kernel, the average F1 score changed back to 0.92. And if we put C at 100, and you see now the average F1 score increased to 0.95. So you can see, because of different kernel and also different parameters, we can have different F1 score. Is there a way we can determine the best model automatically? The good news is, in Python, there is a function called GridSearchCV, can tune all those parameters for support vector machine for us. You can input all the parameters you want to tune in this array. In this example, I put RBF, polynomial, and linear as my kernel. And for each kernel, for example, for RBF, I input the gamma, I want to use those parameters, and C, I want to use those parameters. And for the linear kernel, because only C matters, I only put C here. Then I will run 2 loops. One focus on precision and one focus on recall. And if I run the program, you can see this is tuning parameters for precision, and it will tell us the best parameters found is RBF kernel with a C equal to 100 and a gamma equal to 0.01. You can look at the detail. This is RBF, so C 100, gamma 0.01. You see the F1 score is 0.98926. It's very good. And if we run the tuning for recall, it got the same result. The best parameters is for RBF kernel and also C equal to 100, gamma equal to 0.01. You can go down here, RBF, 100, gamma 0.01, and the score is F1 score is 0.98807. So with this function, we can find our best kernel and also the best parameters for that kernel. This is how I tune parameters for support vector machine in Python. Please provide your comments and subscribe to my channel. Thank you for watching.